All right, so let's move on with the next speaker of this conference. So it's going to be Arthur Luimes, and the title, the Performance Engineering CoE, Center of Excellence, is still a thing. So how to involve your central performance engineering team, especially in the modern delivery model. So otherwise, Arthur, who is Arthur? Arthur is the principal performance consultant. So he has more than 25 years of experience in a lot of areas in the performance space, so capacity planning, infrastructure optimization, and so on and so forth.
Thank you very much, Hendrik. I'm very, very excited to be here. So I'm going to tell you about my experiences I had with the changes that are needed to change a performance competence center. I'll get to what a performance competence center is or could be, to support an organization that is changing to DevOps and changing to Agile. I'm also going to tell you why it is actually needed to change your performance competence center, and give you some generic tips on how to change it. So this is this is about some ideas. Some of them statements may be generic, but it's just to get the conversation going. So after this talk is over, I hope you'll be able to understand some of the steps that are needed to make these changes in this organization and adapt them. These tips I give to your own organization. So here's another title, 8 to 10 good reasons to change your performance competence center, the what and the how. Now, the why do I think is this talk actually important? Because I usually would like performance competence centers to last. I think they are a great contribution to many, many organizations. And but if a performance competence center lasts when you change to DevOps or to Agile, that is not certain. So I have been in I've been very close to one organization in the Netherlands, a large financial institution, I won't mention any names here, where this performance competence center was just completely dismantled. The management thought that the teams were responsible for everything, including all aspects of performance. The teams should do their performance testing, so why do we need a performance competence center? So then these performance competence center members, they were confronted with a choice. You can either be a functional tester or you can be a performance tester in the DevOps team, or just leave the organization. So a lot of them left the organization because they didn't feel like being in the DevOps team. We'll get back to that later. So dismantling such a PCC is not only sad for the people in that PCC, but it turned out to be also a major mistake for the organization. But there were many outages, many performance problems, and then eventually the PCC was reintroduced 2, 3, 4 years later, but only after many losses and irritations to customers and also embarrassing front page news articles. So I'm hoping to give you some ideas on how to prevent this dissolution of the performance competence center in DevOps. Show not only to make sure that you stay, but also to prove to especially upper management, but to the whole organization that your PCC actually has a function also in DevOps and it has a huge added value. So let's go on. So you probably have seen this before, but Agile doesn't come on its own. So what organizations want Agile for and DevOps for is a shorter time to market, but it really is also Agile and so working in sprints and DevOps, working in teams of development and operations together is ideally fit for microservices because one of these teams can just handle 1 or 2 microservices. So it's breaking up your big application, your monolith, into small microservice architectures. And of course, they can then run on cloud platforms. So you can basically get rid of a whole bunch of departments managing hardware, managing your WebLogic service, for instance. So you just take a cloud platform to facilitate all of that. And since you're working in sprints, automation becomes very important because you want things to go really, really fast. So what is this about then? Well, this talk is not just for performance competence center manager, but also for the performance Competence Center members. So I'm hoping that I didn't lose anybody thinking, oh, okay, this is for the management. So this is actually also for you if you're working in a Performance Competence Center. Now, what is actually a Performance Competence Center, and which are the names which I've seen in the wild? There are actually many names. There is also a Performance Center of Expertise. There's a performance team or load testing team, non-functional teams, or even heard the word load testing factory. I'm curious if you find other terms in your organization. What I think is that if you go up the scale here from here, go up, the cleverness increases. Everybody wants to be a performance center of expertise or part of a performance competence center. You're really something, right? And if you go down the scale, the boredom increases. So nobody wants to be a load test factory. Just imagine you're at a party and people saying, hey, what do you do for a living? Never mind, I'm part of a load test factory. You're doing what? Okay. That's not really cool. Anyway, so here's something about a reason to change your Performance Competence Center. That is because, and that has to do with your mission. So here's a brief history of Performance Competence Centers, what they were doing in the past. So from 1995 to 2005, so the PCC was sort of a new thing. People thought it was cool, and most of the people in the Performance Competence Center were involved in optimizing network behavior. So that is because at that time you had very slow DSL lines, dial-up modems, and the network was just very scarce. Bandwidth was not very high. Latency was high. Reliability of networks was also not too great. And people were just building applications, not even minding what the network requirements were. And when they roll out to the end users, then there were big performance problems. So in that time, Performance Competence Centers were very much into not just optimizing the network, but also the network interaction of applications. So the flourishing time of the PCC, the golden time of the PCC is, I think, in that period from 2005 to roughly now, where in a lot of organizations the PCC had the proud statement to be assuring performance, availability, and stability. That was a really great time. It's something to be proud of. You could tell everybody that you're responsible for the performance of customer side X or Y. So that's a really big thing. And now we're evolving. So we're going into DevOps, and I suggest this kind of mission for us. So you can have your own mission, of course, but something I use a lot is then we're going to, as a Performance Competence Center, we're going to support the organization, the IT, and also the DevOps teams with specialized consultancy and complex analysis on matters of performance and availability. And I made consultancy and complex analysis bold, as they are. I'll talk about that more later. So, as I mentioned, some of the DevOps teams will do some of the load testing themselves, and they need to, right? They need to feel responsible for their own software. That is really great. They want to minimize their dependency. They don't want others to tell them what is proper software. That's all really cool. They're proud of what they deliver. And they also feel that, okay, load testing, that's something that I can do. And they're right. A lot of the tests that they do, specifically say unit level load testing their own microservice, is something that you don't need to be performance engineers with 25 years of experience. You can learn that relatively fast. So that is a reason I think why performance engineers should move away from sort of very simple load testing. Let the teams do their simple load testing, their own unit level load testing, and we'll do other things. Talk more about that later. And then organizations are changing. That is the fact in DevOps. We used to have development teams, test managers, and project managers. I'm very curious if in your organization you still have these roles. And then the performance consultant, as I've done a lot of performance consulting, where we would just basically talk to the test manager, talk to development teams, now and then talk to project manager to get budget, and then write performance test plans, look at performance risks, performance requirements. And then that test plan was then, test strategy was then handed over to the performance engineers, and they would just do the work. But basically had very little interaction with people who were actually building the software. The PCC manager was an important role. He was really being the manager. He was there to constantly promote the value of the Performance Competence Center in the organization. Was doing a pretty good job at that also. So now, what is the new structure? The new structure, you will probably miss one term, is a test manager. In one of the organizations I was, within 1 week, all test managers were just fired. They could just become either a tester or leave the organization. So that's a big thing. It's a big change. So there are no more test managers in DevOps, at least not formally. There are people like product owners who are responsible for the product, and above that, for a set of products, a portfolio item owner, and they handle DevOps teams. Actually, I've painted off. There are only one of them, but there are usually many, like 20 or 30 are responsible for the portfolio item. So where are our performance engineers? Our performance engineers in a new role become much closer to the DevOps teams, not completely integrated, because then they would be part of it, but they get really close to the DevOps teams. And the performance consultant has taken more distance, actually. The performance consultant is more talking to product owners and talking to generic architects, or what are the generic risks. But the performance engineer is actually having a lot more communication with the team. A performance engineer, for instance, would actually not just handle one team or consult with one team. They will handle like 2, 3, 4. The maximum was 5, we've seen 5 teams. Whereas a performance consultant would actually be the central point of contact for performance matters, for global performance matters for more teams, 7 to maybe a maximum 10. Another interesting thing I've seen here is that the PCC manager is being actually less manager. As managers, it's not good to be a manager in a DevOps environment or an Agile enterprise. Managers are bound to be fired. So actually, the PSC manager is actually coming more and more close to a performance consultant and actually taking over a lot of the activities that performance consultants also do. So the biggest change, as I mentioned, is the performance engineer. He is getting actually very close to a DevOps team, and that can be a challenge because performance engineers are usually highly technical. They love their work, and they are part of a performance competence center because they're very good at something very technical. But it also means that their attention has been very much on like introvert type of activity, analysis, scripting, production analysis, load test analysis, etc. So in order to be able to communicate with those DevOps teams, performance engineers will need to, some of them will need to be able to open up, to become transparent, to learn, communicate in order to work in these DevOps teams. Title of this slide is Nerds Are Getting Less Popular. So I won't say that nerds are completely unnecessary anymore, or very technical people are not necessary anymore. But if you want to be part of a DevOps team, I think Stijn also mentioned that in the previous talk, you need to have a certain skill set. Fortunately, that can be learned. So you can learn, for instance, to feel other people, to be empathic, to ask them, hey, how are you doing? Is your wife still sick? When are you going on vacation? In order to keep that communication flow present. And also to be present in the team, not just be there at stand-ups and not say anything, but also to be attentive, to ask what kind of questions people are actually struggling with, what the blockages are. If you ask them if you can help solve those problems. And debating and chasing becomes important, not just like giving in when somebody in the team says that the performance test is not needed, but also not go the other way. So to be angry or to fight with team members. So to learn the right skill set in order to debate, to make sure that relevant tests are being executed, and also to chase to make sure that those things which we have being agreed on are actually also being done. And teaching and coaching will get to that in the next slide. That is actually a very important thing. So the company I work for, Altasys, we are actually continuously learning in this from each other in this area of soft skills, and we have a number of presentations and discussions on vision and mission. So why am I doing my work? What am I doing in this in this world? What is my contribution to society? But also communication skills like feedback giving, for instance, or emotional intelligence. So what kind of emotions are there in the job area, and how do I act in that intelligently? And specifically, there's a lot of interest in the area of stress management. So if you're under stress, how do you deal with that, and how do you make sure that those stress levels may go up temporarily, but then get released again? So as I said, nerds shouldn't go away. I love nerds. I'm a nerd myself. To show my dedication to nerds, I've added some of my most famous nerd pictures here. Okay, so then about teaching. Yeah, performance engineers, and they're so close to the team, they need to learn to teach. And so before, competence was meant as something that you're very good at something very technical. But now competence it's actually meant also in the way that not just are you very good at something technical, but also be able to transfer your knowledge, share the knowledge. So teach DevOps teams. So here's a curriculum of courses. I hope you can read it, that I've designed at the particular customer, which go from very generic courses on introduction to performance management, so generic performance awareness courses, to technical performance requirements, non-functional requirements, risk-based performance testing, and then courses on load testing, for instance, load testing on JMeter, on automatic load test environments, courses on the front-end performance, mobile performance testing, and then Java performance coding, and Dynatrace, garbage collection, and troubleshoot courses. How do you troubleshoot performance problems in production? Then courses on network, Wireshark was an interesting course, and finally a course on capacity management, which we developed. Now you can wonder, so how popular were these courses? So these two, creating a generic sense of performance awareness and knowing what the performance requirements were, they were mandatory for each team. So we taught these courses to a lot of teams, and generally appreciated very well. And these courses on load testing were more like for people, the testers in the team. Some developers also, the front-end developers were taking courses on front-end performance testing, and Java developers did some of the courses here. And you go down the scale, the less popular the courses are. For instance, a course on capacity management, which I painfully designed, nobody ever took. So this shows that capacity management is really not something that is on the mind of people in a DevOps team. So we used to be focused on technique and execution, but actually we need to go to coaching and technique, and we need to go into the teaching role, and we also need to go from a scripting role into an automator role. So here's another reason to change the things the way that you're doing in the DevOps or Agile environment. And that is, we need to test a lot, and we need to test very quickly as well. The title is, by the time you've created the script, you're too late. So there are, in Agile, as probably most of you are aware, there are sprints of 2 to 3 weeks. You really don't have time in 2 to 3 weeks to do a very, very thorough analysis of everything that's happening in production, and then try to simulate that into a load test. And so everything will need to be done as automated as possible. And not just load testing will need to be automated, but also things like production analysis, scenario creation, script production, load test analysis, and also the reporting on it. So to help with that, Altasys created a tool called Altasys Eddy, after, of course, Eddie Van Halen, the most famous Dutch rock star, probably one of the most famous rock stars in the world. And Eddy, we call it Eddy after we got the invitation for this for this series of workshops is that our acronym stand for Extended Dynamically Designed Integrated Engine. For performance testing, you don't need to remember all of that. Remember, it's EDDI. And another thing you don't need to remember is that the formal name is the ELTISIS Continuous Performance Engineering Framework. Anyway, just boring. Forget it. So what does EDDI do? So it consists of a certain number of components. For instance, there's a CI tool, and then there is a database having a lot of analytics data in it. In the CI tool, and then there's a set of scripts that can query production values and then have data returned to it. And then there are scripts to update scenarios automatically based on the production data, and then push that to the central database, and then also push that scenario into a load test tool. And the load test tool will then do the load test and then run the load test and analyze it automatically, and then push the test results to a performance database. Now, which tools did we use? For the CI tool, we used Jenkins. Splunk we built a Splunk app for everything on the right-hand side, all the database-related activities, and we use JMeter for the load test tool. But this can be done with any kind of CI tool, any kind of database or time series database, and of course you can also do the same thing for Neuroload, for instance, for other load test tooling. So another reason 8 of 10, so almost there, hang in there. Your performance engineers will need challenges. So load testing microservices eventually will become boring for your load tester who has 20 years of experience. A microservice is usually a very simple thing, and there's not a lot of variation in it. So if you would just let them do that, then they'll be extremely bored and just leave. And also, of course, performance engineers is usually relatively expensive, you could say, and it's actually the kind of work can be done by other people as well. So what do performance engineers then do? Well, they do complex work and stuff that the teams cannot or will not do. For instance, some very complex end-to-end type load testing involving like many user clicks and traversing many systems and with a variety in user population. So here is a picture you probably recognize from your applications. There's a user on the left who clicks somewhere, and then this request travels through the whole chain, goes to different databases, and then returns. So there is no individual team who will load test all of this. So this is really our possibility as performance engineers to keep being responsible for this kind of complex change. So individual product teams simply can't cover those areas. So if you're into challenges and also to see where our our performance engineers are good at is also to create production-like click flows. So here is a click flow where a user, by the way, this is a tool called Disco, which I like very much. You can do many things with it. It's a process flow tool, but you can also feed it access logs, and it will just find the click path of your end user. So in that case, in this particular case, the user clicks on this screen, and then 80% of the users click on this screen, 20% of the users click on that screen of this screen, 20% of the users click on this screen, and then 30% of that go here, and then they go back and forth, etc. Our performance engineers are very good at this type of work, and they should keep doing this, especially if it gets a little bit more complex. I think this is still doable for the best of our performance engineers. If you think you're really great, well, try this. I think that manually, this is basically impossible to do, and this is real click flows of organization of users through an application that is actually not too complex also, but the amount of clicks that a user can do is just amazing. And usually we just do the happy flow, but if there are some clicks in there which are actually very performance related, like for instance heavy uploads or downloads or calculations, then we need to integrate them into our load test scenarios. This kind of thing cannot be done if you want to do this production like with just a manual analysis. So you need tools like Eddy to do that kind of work. So as I mentioned, your added value lies in things that nobody wants to do. So anything that is team overriding is where the added value of the Performance Competence Center is. For instance, the capacity management of the cloud infrastructure. Thank you very much, Stijn, for your question. You just hit on reason number 9. So that is something that the performance engineer maybe is not completely responsible for, but that where you could really provide input to, specifically because he is hopefully then also doing the load testing and scaling of the cloud infrastructure with a production like ClickFlow and passing through the whole chain, as I've shown in previous slides. So even though microservice is a hot topic, there will be many, many legacy monolith applications. Stijn just mentioned Oracle is the biggest monolith that lives on Earth. But there are also many other applications, which mainframes, for instance, which will not be so quickly moved to microservices, and they still need load testing. So that's something performance engineers can still do. Another area which is difficult usually, people don't have a lot of experience with it in the DevOps teams, is network analysis, SSL optimization, HTTP compression, caching of your HTTP sites. So that is something that is, those are special skill sets that performance engineers usually know a little to a lot about, and will be very useful. And another thing is that setting standards for non-functional requirements. So, performance engineers can make sure that performance requirements of microservices are in line with the performance requirements for the end user screens. So if each of your microservices takes 1 second, then the end user will see probably 12 seconds, and then of course that is unacceptable. So helping setting standards for this non-functional requirements is an important thing where performance engineers can help out, because they actually have the bigger picture of the whole chain that usually is lacking in DevOps teams. And then monitoring also is important. So the whole stack from hardware to microservices, so say the vertical stack, but also the horizontal check. Tracing, for instance, there are many tools, Jaeger, Zipkin, or Dynatrace, AppDynamics, so the last two are the commercial ones that can also help to make it visible. Like if the end user is experiencing 10 seconds response time, which of the microservices is actually contributing most to this response time to help to troubleshoot that, not just in a test environment, but also specifically also in production. So that's where I'm coming back to Stijn on this question. So monitoring the whole stack that is also in production. So lastly, so if you think that people in your team are the smartest people on earth, and some of them may be a little bit nerdy, but at least they're extremely intelligent, we have to watch out. There are some people in the DevOps teams which, according to my experience, are extremely intelligent and they really know what they're talking about. And so it's really good to cooperate with these people. So specifically, this role is not defined in all organizations that I know, but there may be similar roles. It's an ops-like role called Site Reliability Engineer. That is a Google term. It's basically responsible for the stability of the service in production, and also about automating everything that is needed to make sure that this site stays reliable. And developers, of course, and we need developers for many, many things. So we can work together with the SRE and developer in many areas. We can help automate load tests. We can contribute to reliability testing. It was something that the SRE, of course, is actually responsible for, but we can really help out there. For instance, making the backend slow or making it unavailable and then available again, overloading the app and see if the app recovers if the load is lowered again. Playing around with chaos monkeys or chaos engineering is important here as well, just to find out, are there any conditions that the application or the microservice that the team is building is stable and recovers by itself when the weird thing that happened to it is over. And of course, assisting in dashboard creation for production, and alerting is an important thing where performance engineers can have added value, and pushing for tracing and logging in the app. These kind of things are usually forgotten. Performance engineers are very aware how important it is that the tracing is there and logging, performance logging is there in the app. That's an important function. So I think especially the site reliability engineer, that should be that is a role which should be our best friend, right? That's something you really have to drink a coffee with, because that's where, in the cooperation with the site reliability engineers, where we have our added value. So summarizing, so first is, I hope in this talk you got some tips to convince your senior management of your added value in your performance competence center, and ask for the support. Tell them the story, what happened at this particular Dutch financial institution where they have dissolved the PCC and they've got many problems, performance problems in production. But then also do something yourself, right? Develop soft skills, make sure that you learn communication, debating skills, skills on giving feedback is all very important in this highly communicative development DevOps teams. So automating, learn a lot about automation. I know there are many talks in this area already. Cooperate with site reliability engineers, and then make it fun for yourself and for other performance engineers. Because I think working in the DevOps team is not only great fun, where you can learn new soft skill sets or other skill sets, but it's also usually less stressful, because you know, in sort of a big bang implementation in a monolith, load testing is usually done all the way at the end. So then there's a lot of stress on this, and working in DevOps or an Agile manner is usually also for performance engineers stressful and more fun. So that's the end of my slides.
All right, thank you, Arthur. First of all, thank you to take the topic related to organization, because usually this is something that we never really touch base. We briefly explain it, but we don't cover this type of how we should structure and organize ourselves. A lot of people, a lot of experts or blogs, or you can find on social networks, is referring that performance center or competent knowledge center or center of excellence or whatever you name it are dead with Agile and DevOps. But I won't use the name dead. I would say that should be restructured or revisited, I would say, so sort of. So great. That's I'm pretty happy that you picked this topic. There's a questions before we invite the other PAC members connected. There's one question from the attendees, which is: do your core activities also include architectures reviews to identify potential performance hotspots?
Yes, that was true in the old world and also with Agile DevOps. That doesn't really change. That is still a role which sort of traditionally is part of the performance consultant area. Performance engineers are usually not too involved with architectures. It is, however, still a vital role, specifically when it comes to microservices, where architectures are getting more and more complex, and people find it very hard to find out where a microservice actually is, or which microservices there actually are. This is why I think one of the reasons why this tracing that I mentioned, open tracing, is one of these initiatives, why tracing is so important, so that microservices will sort of log where they are in the chain, and also what their contribution to the response time is. So it's a really good question. So architecture changes and architecture design becomes very important. Just to mention something from my own experience. So one of the things that we've seen is that that changes in network tuning, or changes in network configuration, can have a dramatic impact on a microservice, so the Agile DevOps application. So if the whole application chain is consisting of 20, 30 microservices all talking to each other, then they talk to each other over the network. And a lot of the times that is done with SSL, or HTTPS calls. And if you do something wrong in there, you dramatically increase the response time where you can SSL handshaking for every request, for instance, or SSL pooling is not properly defined. Not only does the response time suffer, but also the CPU. You can actually blow up the CPU of your whole cloud cluster because all of this handshaking is extremely CPU intensive. So that is something sort of generic areas in architecture where there is a generic thing of all microservices talking to each other, or all microservices being moved from, say, Amazon to Azure, or the other way around. That's something where performance consultants and also performance engineers can have an important role.
We have a question from Alexander Podelko, by the way, one of our PAC members. So hi, Alexander. So thanks to be connected. So any examples of performance excellence centers in new DevOps organization that didn't have them historically?
Yes, there's definitely a number of examples. I must say that some organizations are already very, very far with DevOps. Other organizations are still sort of struggling to get there. Organizations that are really far and have successfully managed to change in their performance competence center, they are really successful also with the reliability of their microservice infrastructure. I won't mention any names, but I worked for a couple of years at one of these customer sites where we made this successful transformation, which also is inspiring, I think, for most the slides that we see, all the things I learned there, that is important to show your added value to the organization. I'm still using today also with other customers.
There's another remark related to the architect questions. So your remark on my architecture question suggests that there is a need for a performance model to characterize the demands created by the interactions between the microservices.
Yes, absolutely. And there is a need generically, I would say, to for a review by performance experts, performance consultants or performance engineers, of anything that is touching the platform. I would call it that wide. Anything that's having to do with hardware change, with platform change, Java upgrades, Spring upgrades, network interaction, SSL changes, new databases. There is a need there for a performance consultant or performance engineer to come in and to talk to the architects on these topics, which could have a big impact on the whole microservice infrastructure.
The complexity with that team is what I see is what I call the culture change. Going from the old world to the new world and really embedding performance within all the DevOps teams and making that shift so that performance really matters. Did you cover that, and what's your advice there? How should we start with this? How do we do that?
Yeah, very good point. Yeah, there are different ways you can do this. I covered this a little bit. I mentioned your names, I think 5 times, Stein, in the presentation. So, but you can look at the recording and count the number of times I called you. I think so. The number of ways you can do that. First of all, you can, if you want to do it very formally, you can go up to the upper management and say, "Hey, here are the performance requirements for all of your microservices. All microservices should." And there are a lot of shoots. They should comply with these performance requirements. They should be tested and should blah 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 blah, etc. And then then you can check if the teams are actually doing it and doing it right. But actually, I like the approach more that we actually educate the people and make them performance aware. So what I was doing at this particular customer is actually creating a number of courses in the area of performance management and performance testing and performance tuning, and also capacity management, that people could sign onto, and then take those courses. The generic courses on performance management, which are actually performance risk. What is the performance risk, and what are the different components of performance management? So not only load testing, but also analysis in production, and tuning in production, troubleshooting, non-functional requirements, etc. So that whole package. Those courses were given to all team members. So after those courses, at least what they remembered, I hope, that performance is important, right? So and that they have created in the workshop their own performance requirements, and then other courses were optional. So on load testing with JMeter, for instance, or Dynamics or Dynatrace or Jaeger or of these courses. Yeah.
What I hear here when I was talking about the technical depth and innovation, I think that we also need a culture budget. Huh?
Yes.
In a way that there is also time to make that culture shift, because if it's not a buy-in and there's no time to do the courses, and then it's just not happening. And you can say, the definition of done, a definition of ready, you need to have something about performance. Most people wouldn't have a clue. And what you said, the first 5 minutes I listened to you, you said you can shift the easy stuff to the development team. Yes. And I know that the execution, recording of a REST call and executing the REST call or whatever, that's easy. But if you then look at really interpreting the results and understanding that there is an architecture, that you have virtualization, that you have, and that you have maybe shared environments, that's complex. Most people, I have Java developers that don't know about a heap. And they still exist, and they're really good. They can write really good Java code. And then people speak about where to go to, but the reality is sometimes so far away. And my conclusion is here: buy in from the top and have budget, so there's time to actually make it happen. If that's not happening, you're chasing your tail and it will not happen.
Exactly. Yeah. So I think that's one of the reasons why the buy-in from upper management, from senior management, is so important. The senior management could say things like, I allow all teams, all product owners, no matter how much pressure they have to deliver functionality, but I allow them to have 10 or 20% of the time in the sprint to work on non-functionals, or 10 or 20% of the time to do training, right? To be trained. But then, and then of course, if we have these courses, then that can work. So that's why the buy-in from upper management is so important. So that's why my whole presentation was about giving people who talk to upper management the right wordings and the right arguments, so that they convince upper management that the Performance Competence Center still has a lot of added value.
And you're speaking again this topic about how do you monetize performance testing, which is also not an easy theme. How are you going to put a cost value against the effort that you need to do to actually make that culture shift? That question is very complex if you don't have an e-commerce website. Yeah. And then even convincing, and sometimes you do need, and again, and it's sad to say, a bit of a disaster to actually shake up people to make it happen. And I don't like that. I don't like to make fun of it on LinkedIn. I never do that because those things happen, but sometimes it needs to happen to enable the change and to actually make it happen also top down. Taking over, sorry.
Roman, do you have any questions for Arthur?
No questions. Really interesting talk. A few thoughts came into my mind instantly. So we've been dealing with this a lot. What you talk about is achieving the biggest thing ever possible, like the digital transformation, to call it by name, changing the philosophy from silos to actually DevOps in a huge environment. And congratulations if you manage to contribute to this at your customers. We do this as well, and we see a couple of obstacles there. And of course, one is that Steen mentioned already. It's an investment. If you want to make the shift, you have to invest in this, and you need the upper management on board. So to have it on board. So I can, I don't have questions, but I really want to underline this. And I have one more statement. I think because this has not been done in the past, let's say 3 to 5 years, and it should have been already, that these groups that you said, like whatever you call it, like let's call it performance center of excellence. I think they are going to become more and more important, because I 100% agree with Steen when he says the performance test concepts, they are not aware to all the individual developers. So they need somewhere to go to, somewhere where they can learn it. So I really like these concepts. We do it the same way for, at our customer sites, and we have a huge success there. And I see that the demand is going to be increasing in the next years. So it's really exciting to be a performance tester nowadays, or a performance engineer. But you also, of course, have to shift to this new philosophy that you mentioned.
And like you mentioned as well, there's no clear training or courses to become performance engineers. You learn on the field and by making mistakes or whatever happens. So even if we want to give the lead to lead developers or lead architects, say, hey, come on, do your tests. There is a clear, I mean, Steen, you mentioned there's clearly and obviously people at one stage, they won't be able to understand a few data or a few things that are related to performance. Because if you look at your scope is just this and your test is this, obviously you don't have the full picture. So it's more complex.
And it is complex. You remember all those little, the slide with all the little spheres, hardware configuration, and that's all always in the context of one application. So that's probably why there is not a generic course, because every application is different, and you will always meet different software packages that need a different way of testing. And there is so much to learn. In the beginning, it was you gave knowledge to someone and you could do testing because you did black box testing, and that was it. Luckily, that's not the world anymore. But where do you start? It's complex.
Performance testing is complex. I agree. On the other hand, we now, because of the limited scope that DevOps teams have on their own application, right? They basically load testing their own application. We can teach them some basic skills, because their microservice is actually a relatively simple thing to load test. Even though, like you mentioned, there's virtualization and there's people don't know about garbage collection and automatic Java tuning and et cetera. But still, here we have a chance now, because the scope of the application is getting smaller, to make people performance aware, make them interested in performance testing and performance tuning, and then also, to make sure that the application eventually is also more stable. So I think DevOps and Agile is also a big chance for organizations to sort of spread performance awareness to the whole organization.
But then having an architecture that is already on microservices, that also have infrastructure as code, that having a new environment is like, if you're already there, then it's actually easier, because then it works. But if you have an in-between monolith which is, we don't know what's really happening, and you need an app dynamics and a dynet trace to just see how everything is connected, then it's a different story. So the ideal is that microservices, cloud, auto-scaling, infrastructure as code, then I do see that happening, of course, but in between, it's a bit more complex. But to agree, we need to do it because we can't do everything ourselves. So working at doing a performance testing as a service is a way to go, because you need to be honest, you can't do everything yourself. So that's true as well.
I would like to thank you, Arthur. Thank you to be part of these PAC, the PAC Hero. Thanks for building that content and presenting it. That was really useful and meaningful for everyone. So thanks, and I hope to see you soon on the next PAC event for sure.
Thank you very much, Hendrik.